Hi everyone. Yeah, so excited to be here and see a lot of people curious about Firestore improvements. Yeah, and by the way, I just wanted to be on the same page. Can you raise the hand who use at least once Firestore in your applications? Yeah, almost everyone. That's great. Okay, I mean Firestore, not only Firebase, Firestore. Okay, anyway. So, yeah, my name is Max. I'm iOS engineer, and I don't have so large experience like you are, but I started from React Native development and smoothly transitioned into the native development. Yeah. I worked in a bunch of projects, but mostly it was financial projects, and then I will tell a little bit more about this in the few minutes and next slides. But also, I need to tell about that I'm also an ambassador of software heritage. If you know something about like Web Archive, it's almost the same, but this community archives source code from any kind of like GitHub, GitLab, Bitbucket, whatever. So you can, if you have something like a public repository in your account, so you can check there. Probably it's already there because they made a crawling technology. Yeah. Also, I'm pretty actively writing articles, so you can find me in Medium. HackerNoor or DZone, for example. Today I'm talking about Firestore, so also I wrote an article, and you can find it in HackerNoor. And yeah, I'm working at that adorable company. I would say we are building a cool technology, and what I wanted to say, we are like a classical startup in San Francisco, and our office looks like this. It's a Bograt, it's our strategy manager. So yeah, it's pretty important. And what we are doing, so maybe here there is a game developer for iOS, so we are targeting iOS, and especially for game developers. Let's say you have a skill-based game, and we are developing XC framework SDK for game developers. They can integrate this full stuff into the game, and actually we helps to monetize the game through the tournaments. And here's a list of tournaments. I will just walk quickly. Here we help to find an opponent from database. Okay, we found. Yeah, so matchmaking's happened, and player can play the game, and the result game over screen with the scores. So pretty simple, but a lot of stuff. But why I shown you this? Because yes, we are using Firestore. Of course, before that, in my pet projects, I also used Firestore, and a lot of thoughts about this, and I collected a lot of experience about this, and I wanted just to express for someone about that. It could be better. It could be some kind of better. So what I'm going to show you, I'm going to show you some particular methods, helpers, how it could be improved in your current project, or maybe in the future if you will come to some potential client or job, and they would use the Firestore. You can suggest something. Yeah. So it's my agenda for today. I hope I will be on time. So we will just quickly go through the Firestore documentation. We will discuss about mapping problem that you probably know already, and I will explain what's about request and response approach. We'll try to make a get document and documents method. We will talk about querying, listening, error handling, maybe something else. So yeah, let's get started. Okay, Firestore documentation. Yeah, like probably you know all even better than me. It's Firestore. It's a document-based NoSQL database, and actually a client application running on device, and it's established a connection between cloud Firestore, where exists Firestore storage, and so. And actually, Firestore front-end UI we are using for checking how it's going in Firestore storage, actually. So yeah, how it should be configured, all it's just we are using app delegate. Yeah, did finish launching with options. We just need to configure it, and yeah, I won't go through how to install it. About plist that we need to drag and drop into the project. So I will show just this coding stuff. Yeah, and yeah, so we just need to define this database itself, and like they are presenting on documentation like how we should set the data using dictionary. Yeah, so like okay, of course I used it in my first projects, but it was a little bit not comfortable. Yeah, and how we can get the data. Also, I just grabbed this snippet from the documentation. Yeah, so like, okay, we can use it like this, but let's talk about codable. Like from my experience, I come to this approach, like because we are like we can understand communication between database with Firebase. Yeah, let's say it could be request and some response. Yeah, so we just request some data and we just expect some response. Like, okay, it could be maybe naming not so well. Maybe it's in Firestore language, it's a snapshot. Yeah, so let's make a request first. It should be something like a request. Yeah, I mean a protocol, something where associated data could be a response, and also we need a path to the exact place where we need to get this output. For example, it's a document or documents, whatever. For now, it doesn't matter. Just like we need to understand like there is a request with some path and response. Response is just a codable thing, not so big deal. Okay, let's make a get document. So okay, here I am presenting extension of Firestore, but of course it could be something different, some more abstract layer somewhere. Yeah, but for more understanding, yeah, let's make an extension of just a Firestore. Yeah, and let's define a couple of methods here. And here you could see like we can get the document, and we pass the request to this method, and using this request we can get the path. Yeah, and we can get the document, and also we need something to convert our codable to our expected object. And it's like a mapping data problem. I call it like this. Yeah. So if we are install this Firestore, so it will be like what we will get. If we will use the document snapshot data, we'll get this just dictionary. Yeah. So we need to improve our dictionary extension using JSON serialization and decoder, and we can get easily this codable. And yeah, Firestore has this document snapshot where we can extend this document snapshot with data as a type, and we can get our expected object. And yeah, so finally, it looks like this. I already shown you, yeah. And so already we can use our request and response using this this method. Why? By the way, the two methods shaded. It's here. It's not necessary. It could be just one or whatever. Like maybe someone would use just path. Yeah. So yeah. Regarding how we could build it more, I would say, structurally. So I suggested to make like another layer. Let's call it session. Maybe it could be another name. And from developer perspective, it could look like this. So let's say we have a couple of domains, what we need to get, yeah, from Firestore. Let's say it could be app config, yeah, it could be users, and so structurally it could look like this, yeah. So let's start with, for example, app config. Yeah, we need to get like this object from Firestore. It's placed somewhere there. So we can define it like this. It's a response, yeah. And the request itself looks already like this, yeah. So it's a struct with expected output app config, yeah, and the path to the exact document in Firestore. And from already the session object, the method could be just easily named get app config, where we expect this app config using the request from Firestore, just get a request. By the way, here it's a small mistake. It's get document. I just forgot to change it. Yeah. But anyway, also, by the way, I don't use here completions. I'm trying to use this async await approach from Firestore. So because it's already broadly usable thing, so why not? And already somewhere in view model, if you are using MVVM, yeah, we can get this data just using try await beautiful session and get app config. And yeah, that's it. And also I duplicated like literally how it could be from the Firestore UI, yeah, for your understanding. Okay, what about get documents? We need to improve a little bit the document snapshot itself. Not the document snapshot. We already did this, but regarding documents, there is another thing called query snapshot, because we are not using reference to the document. Firestore provide a query to the particular collection, so we need to improve it. It's also pretty straightforward, because actually it's a collection of documents, and we can use that higher order method, compact map, where we already defined where we can just use this data from that document snapshot. So yeah, just highlighted that couple of things here. And yeah, like as you can see, it's also looks pretty the same, like we did it already with get document. So like it's just called already get documents, pretty straightforward. So no need to, yeah, it's just the difference only is we will get an array, we will get a collection. And how it could be designed from session perspective. Just let's say we define this object, expected object. Yeah, let's say it will be a user with username, user pic, whatever. The request, yeah, with a particular path and that particular output type user. And the method itself. Get user, a user collection, the request, and we can get these documents from there. And it looks like this. Yeah, also pretty neat, I would say, and understandable for everyone in your team, developers team, so they can understand where you can add something new in this session. Yeah, what you need to use. So it's pretty convenient. I mean, like from my experience, it really works like this. So you don't need to read something additionally. So just you can use this session. That's it. Okay, query. What about querying? Yeah. Yeah, I just put this additional slides, like how we can extend this request. Because why we need this request response, and why? Because we can extend them in our purpose. Let's say something weird here. Sorry, it's from documentation. Yeah, so from documentation we can use some reference. Yeah, reference code. By the way, it's a query where we can add this queries methods. It's native Firestore stuff. Yeah, but from our perspective, if we are going to use only requests and to get some response, we need to have something inside of our request. And I suggested to have a request query where we can collect cases, what kind of queries we could potentially use in our request. So let's extend it. I mean, here you can see the queries. Yeah, probably I highlighted it. Yeah, the queries. Yeah, that we could use. And what else? Yeah, and also in extension, it's just because it's optional. Should be okay. From Firestore perspective, how we could convert it. So it could be just a typical method. I call it query, where we just go through the list of potential queries in potential request, and we are changing that query from Firestore. And eventually we return the updated query that will be already usable for particular request. So in case of get documents, which we can change the reference query to the method query request, and it's also always will be like this. Yeah, get documents. So if something inside of request, I mean some queries. Yeah, so we can filter, we can limit, we can use an as predicate, whatever. Yeah, so I just highlighted again here. Yeah, so let's extend our request to get, let's say, user followers. So just an example how we could see that request. As you can see, we added queries, and let's say we will limit it to 3 items, yeah, and filter it using an as predicate. Followers contains that ID, and yeah, and eventually the method from in session could look like this. Current user ID, we just pass it to the request, and we are using this request to get these documents from Firestore. And how it looks from the view model. Again, just a few lines of code where we can get the followers. So pretty simple. And yeah, listening. Listening, it's a little bit different thing. And what I can say, that we need to a couple of things. First of all, we can't use async await listening Firestore. We need to use completion there. So better to improve it to have an approach using result with some expected data and error. And also, I suggested to make our own error. Let's call it Firestore error. Firestore error, but by the way, it's not exist Firestore errors. It's I would like to see this, by the way, personally, but unfortunately, I will tell you a little bit more about this, how it looks like from Firestore perspective. But anyway, so let's listen a document, yeah? So of course it could be some document reference, and as I said, we will use completion, yeah? To listen documents, absolutely the same situation. And yeah, from the and how we could make this from the session, I mean method, yeah, the same request. We can use the same request that we could use for, not for listening, yeah. It's also already cool. And yeah, so we could use this listen document with just a completion. And the same situation if we are using listen, if you want to listen just users. As you can see here, an example of that we are just reuse these requests. So pretty convenient thing. Okay, a little bit error handling because I didn't show you that part there. I just cut it because it's a little bit different way. So it was like this, yeah. Okay, it's delaying, by the way, a little bit. I didn't figure out. Okay, yeah. So what about error handling? Like I said, Firestore doesn't have their already cases that you could get from Firestore. Yeah? So we need to handle it somehow. And if you would check Firestore, there is an interesting object called Firestore error code, where you could pass an error inside of it, and we can handle it somehow. Yeah. So it's an example here. Yeah, from the source code of Firestore itself, it looks like this. So they pretty well documented each of cases there. So we can handle it in, let's say, in this way. Of course, it's not necessary to be like this, of course, but it's an example of that. You can handle a lot of cases from that Firestore error code. Yeah. So yeah, and a little bit more about listeners. Yeah, so you already seen this, yeah. All is good, but what about if we are using multiple listeners in our application? We need to do something with it, yeah. Documentation from Firestore, they provided this approach, like you can define the listener and you can just remove it, yeah, whenever you want. What we can do with this, yeah. And this listener called the type, it's listener registration. So okay, let's do something with it. We can extend Firestore where it could be, yeah, where main thing, it's a property listeners. It's a dictionary where a key will be a path in the future, yeah, a path from the request, and the listener registration, it will be a value. And why? Because we could add the listener there. We can remove a value from, I mean, like the particular listener from this dictionary, right? And also we can just clean them all. If let's say if user log out from application, we need to stop all listeners. We need to remove them, yeah, from this dictionary if we are storing there. Yeah, to check, does it exist in something in that dictionary or not? We just can extend the dictionary. I just literally shown for you this additional helper. And yeah, so how it looks from Firestore extension. So first of all, we are checking listeners for existing path. So it's if it's not there, then we can add it. Yeah, there. And yeah, it's pretty obvious because also I would say like it's a little bit weird to check the key that because the dictionary, the key is a unique thing. Yeah, but why we need to check this? Because if we if we set something to that dictionary, then the listener will be just substituted but not removed from there. So it will be still exist. Yeah. Okay. And yeah, listen, documents, it is a little bit different thing because we need to pass you need to pass a particular path to check this, not to check to add this listener to the dictionary, because to get documents we need to use queries. Queries we can get a path from query from document reference. We can get this path, but from query we can't. And also, yeah, something else. I remember I built an application, just an educational application where I used for the first time Firestore, and I already saw like, okay, we have this Firestore and also Firestore Swift, Firestore combined community. I thought, oh my god, interesting. They already like provided an implementation in Swift, and I just removed completely, as I remember, Firebase Firestore and just imported without reading Firebase Firestore Swift, but it didn't work because they provided just helpers. So you need to just import a couple of things, and what they have, by the way, an article about this, yeah, and they did the same approach that I just told you, but without this request response stuff. They just give us an approach of handling codable things. And yeah, it's also right from that documentation how it could be, yeah. And as you can see, they are used the same thing, data as the type that we are expecting from Firestore. Interesting. And also, yeah, here how it could be looks more. Get document as a type, also pretty convenient. And yeah, if you are using async await, so it could be like this: get document and as a and expected type of object that you're trying to get from Firestore. So yeah, there is a list of links that could be useful for those who are using Firestore. And here also I added Firestore exception code. It could be interesting to read, yeah, about that, about Codable. And also I made a GitHub repository of everything what I talked today. But today, for example, I didn't tell about how to update data, how to delete data. Also, it could be handled using these requests. But you know, I don't recommend using in this way because like it's not secure. If you are have some kind of backend, better to use backend. But the cool thing of having this request, it's because you can convert to using not only Firestore. You can use with another type of database implementation, because anyway it will be some path somewhere. Anyway, you will expect some data from somewhere. So maybe in the future you would say like, okay, I don't need for now using Firestore. Okay, but request and response, they will exist anymore. Yeah, so I tried to make this yeah, Firestore better. And yeah, thank you for listening.
Does anyone have any questions for Max? And please speak up because we only have this one microphone. And Max, if you want to even repeat the question after they ask it.
Yeah.
Any questions?
There's a question on there.
Yeah, Chris, do you see any on the computer?
So Edward on the Meet, if you want to unmute and ask your question.
I can unmute. How nice. Thanks. So I've been using Firebase for quite a while, and I have a false compiler error issue that basically if I do a get documents as my object.self, the error message comes back, argument passed to call that takes no arguments. And it just shows up in Xcode anywhere I use that call, but it's not a real error message. It compiles fine, it links fine, it runs fine. Can't figure out how to get rid of that false error message. Any thoughts?
Yeah, if I understood, it's a problem with error handling, right? So we need to catch the particular error, yeah, right? Am I
No.
right?
No, not an error handling issue. It's actually, I think, some sort of namespace. I don't know if it's namespace issue or something, but that get document as must be overloading something, because it's basically thinks there is no call that says as with a property as. The argument passed to a call that takes no arguments.
And it does work, is what you're saying.
And it works just fine, but Xcode continuously shows that as an error.
Did you clean and
It's-
derive data?
Oh yeah, clean, rebuild, re-import. I've been seeing this error for years, and I've Googled it, I've looked around, and I've seen other people have the same issue.
Basics are, yeah, because we are using all only our own stuff, and we don't use this Firestore Swift, so probably that's why I don't know about this error. So, but it could be, yeah, why not? Yeah, could be.
Okay, I suspect it's a Firestore Swift issue, because that's what
Yeah.
I'm putting
Yeah,
to use.
yeah. They, I remember they pretty long time was like a beta version of Swift, Firestore Swift, and only now I wanted, okay, I need to check what's going on there, and they're already not a beta version, but still have some problems probably.
Okay.
Thank you. Any more questions? Okay, well, let's give Max another round of
Hey.
applause.
Hi, so I'm Kabir, and I am currently working at this place, which I realize is not listed on the T-shirt, even though I've been walking around telling people to read my T-shirt, and I realize it just says "Grow Without Fear," which is not the name of the company. The name of the company is Ramp, and I will go into that briefly. But before that, I have some quick questions about using SwiftUI. So, can I just have a quick show of hands? I'm curious about how many of you have used SwiftUI. Or just played around with it at all. That's a lot. Okay. And how many of you are currently using SwiftUI in production code? All right, that's like 50% or something, which is pretty inspiring. My goal here is to turn the other 50% of you as well. So yeah, let's get started. A little bit of background about me. I have been working at RAM for about a year, and I am sort of between interning and working with them part-time, because I'm also studying at the University of Waterloo. And a little bit about Ramp to begin with. So we simplify finance for your company. We're a B2B SaaS company. We have a few different product offerings. Our goal is to save you time and money. So we offered your employees virtual and physical credit cards and allow them to make reimbursements. We do finance automation, bill pay, lots of other products. Our mobile app is primarily catered around this cardholder experience. So like I have a physical version of the Ramp card here. Whenever I make a transaction on it, that's going to show up on my Ramp app. And I hope I didn't show all of the details. It's a good thing I can also lock it from the Ramp app. But yeah, so that's the idea behind the app, is that it allows you to manage your cardholder experience, submit memos, receipts, transactions, everything like that. All right, so we started building the Ramp iOS app last year. We've existed. We've existed for a while as a company, but the mobile app is relatively recent. So just last year, we started building this iOS app. And we were all experienced with UIKit before this, but we'd been seeing the developments in SwiftUI, especially last year. Like iOS 15 was kind of the time that we had heard whispers of it actually being mature enough to use in production. we were also really, really excited by SwiftUI because, you know, it's what Apple is pushing these days. So many of their new features are SwiftUI only, such as widgets. And also, of course, it's really great to get more people excited about RAMP too, like on the developer side. Um, Plus, we knew that there's also going to be escape hatches, like if we need to go into UI Kitland. And I think what's really important here is courage. I think we decided that we would demonstrate some of that. If Apple could do it, we could as well. So yeah, the goal was basically to build a SwiftUI app without compromise. And that's the most important part of this. We wanted to not compromise on product quality, and our app had to be up to par with an equivalent UIKit app, if not better, and ideally better. And the point behind that is that we knew that we wanted to build the best experience possible for users, but also iterate really, really fast, because Ramp is a super fast growing company and we're constantly adding new things. So this was really critical to us. Now, here's a brief demo of what we wanted the app to look like. So this is the home screen, just the home flow for this doc. And a few different things, particularly focused around navigation, are being demonstrated here. So as you can see from that video, we have quite a few complex interactions, right? And it might seem like these are kind of tricky to implement in SwiftUI. Just to briefly go over them, we have these modals that can be dragged down and back up, like detents. We have more modals that can be presented on top of the existing modals. And then, of course, and this is the most interesting part of this interaction, is this navigation stack, probably, which is like when you tap this, you do kind of a magic move into the next screen. And okay, my screen froze. That's not ideal. You know what? I'm going to need a second while this fixes itself. All right, I'm just going to switch back to the main screen. Sorry about that interruption. Cool. So yeah, that's the wrong one. Yeah, okay. So yeah, let's just look at that video again. Just that last bit is this navigation stack. If you look at the top bit, it transitions from modal to full screen, which is not a native interaction typically that you would see with existing product. And these are just two requirements highlighted here, right? Now the question becomes, okay, what are the ways to achieve this in UI Kitland? You would probably use like a dot full screen sheet, because you can't go from modal to not modal. And then you'd have like a mask to round the rectangle. It gets kind of complicated because if you have a navigation controller as well, navigation controllers do not like being masked. I learned that the hard way. Now, moving on. Yeah, that's what we would have to use for magic move. I'm not even going to try saying it, but yeah. I have used this API and I hate it. And I think a lot of us have had horror stories with it, right? Yeah, I see a lot of nods in the crowd. So that brings us to the first lesson, which we learned, which is in SwiftUI, building these wheels is easy. So initially, we also played around with using SwiftUI's navigation view. You can imagine how that panned out. Instead, we opted to actually hand roll our navigation stack. And the way that we do this is interesting, and SwiftUI makes it really, really easy to do. So because SwiftUI is declarative, for example, if we want to show and hide the camera dynamically, we literally just have an if statement. It's that easy. If you want to change the corner radius, you, again, just have like, you can have a ternary or an if statement, however you would write your code. And the animations are automatic. Now, that's really cool, but another really cool thing that we got out of that for free is because we hand-rolled it all in SwiftUI land, we use this thing called matched geometry effect, which is like magic move in Keynote. You assign two different views the same matched geometry ID, and it just magically transitions from one to the next. That's what you saw on that screen with the cards moving out, and we use that quite a bit across our app. So that was lesson one. Lesson two is you deserve nice things, which is a reference to this talk, which is a really great talk. I would recommend watching it if you get the chance. Just search for these exact words. And the idea behind this is that in SwiftUI, writing extensions to enhance your views is really, really easy and really, really powerful at the same time. And what I mean by powerful is that you're writing just a little bit of code and getting massive value out of it. And on top of that, it also makes it so that at call sites, it's really easy to use these view modifiers and other sorts of extensions correctly, while also being really difficult to misuse them. And that's just the goal of any sort of code you see, right? Like that's the point. That's the reason we have type systems, is because it's about making it difficult to write bad code. I just included that because it was funny. So one thing that we realize is small helpers can be a big help, right? We have all of these property wrappers in our code, and the thing about SwiftUI is that a lot of the things that Apple does, we can do as well. So like if you look at this animation or this environment modifier, right? That is that's an Apple thing. We can also make our own modifiers like current theme, current spacing, current power state. And that is all powered by dynamic property, which I will briefly talk about. But there's also all of these other amazing utilities for doing the exact same thing or similar things. The point being that you just unlock so much power out of this that you would require a lot of boilerplate to get in UIKit. Like in UIKit, views are expensive. In SwiftUI, modifiers are super cheap. So here's an example just showing the current theme property wrapper. This is using environment, which is also something that we find really handy. So with environment, you can basically inject things into your view hierarchy, like way up, and then somewhere deep down, you can access those things and interact with them, either read from them or write to them. And this current theme kind of combines the concept of a property wrapper and an environment object. So it gives you access to the current theme, and it also allows you to modify it. And just as an example of the modification, here's a debug menu that we have in the app. And I have a video here. So we have colors and text styles. You can modify all of this. It updates the entire app live. The same thing with text. The point is, it's just so easy to do this with SwiftUI that there is no reason not to. Yeah, this is the SwiftUI way. Who's watching The Mandalorian right now? Anyway, so the other good thing about SwiftUI, and a lot of people talk about how, okay, sure, a lot of SwiftUI things are, like SwiftUI isn't powerful enough because you often need to tap into UIKit. And yeah, sure, like we didn't have a photo picker until iOS 16. That's ridiculous. But the good thing about SwiftUI is that we can still add all of that stuff ourselves. And it's so lightweight that there is no reason, again, not to be doing it this way, and rather to be using UIKit from the top level and then SwiftUI in little components. We found that it's really easy to be using SwiftUI across your app and just have those little escape hatches where you don't have enough power with SwiftUI to be able to tap into UIKit's power. And yeah, like this little update bit is kind of magical. It allows you to synchronize your SwiftUI state with your UIKit state. And it's what makes this view behave like a natural SwiftUI view. And this is hammering in the point that I made initially, is it's easier to write good code than bad code. This is just a concrete example of it. So if you look at like this small padding modifier, right? In UIKit, if you wanted to do this, you would have to write a constraint, and then you'd have to type out translates auto resizing masks into constraints or whatever it's called. And then it's just so much easier in SwiftUI. And it's, again, with things like padding, for example, it's accessible by default. It's dynamic type aware. And it allows you to just compose things really well. And then like we have another modifier here, which is safe area inset, which is a built-in one, but it's nicer than the UI kit variant because it actually allows you to put your view inside of it. So as you can see here, like this scroll bar doesn't go all the way up until the drag handle because we have a little safe area at the top here. And yeah, the dynamic type awareness means that, you know, we can resize things, and if we wanted to respect the accessibility sizes, it would. Yeah, so that brings us to lesson 3, which is that dynamism is a function of architecture. And this is going to address another controversial point that people have about SwiftUI, which is that a lot of people believe SwiftUI is incredibly rigid, right? And I mean, just literally look at the examples from Sentry and Datadog's SDKs. You want to trace SwiftUI code, you have to wrap it with Sentry traced view, 3 times in this case. And then, like, you know, every time you have a button, you have to like add a modifier onto the button just to track it, right? A lot of people believe that this is how SwiftUI code is. That's not true. The solution here is actually really easy. And if we sort of take a page from UIKit, right? In UIKit, you have view controllers. And the way that people do it over there is they swizzle view controllers and they extend them with this kind of stuff. In SwiftUI, it's even easier. You don't even need to do any of that swizzling stuff. You just need to have a common choke point. And that's sort of our own term that we're using here. Basically, the idea is that if you have your code go through this common piece of infrastructure, then whatever you write within that infrastructure gets applied to all of your code. One example of this, so in UIKit, you might write subclasses. In SwiftUI, you can extend protocols, for example, like you can extend the view protocol and write your own custom view type. But what we found even more helpful than that is, so in our app, we use this thing called the composable architecture, which is great, by the way. I could have a whole other talk about how we use that, and like we actually develop upon that and have improvements to it. But regardless, the point behind the composable architecture is that all of your functionality is located in this thing called a reducer. If any of you are familiar with Redux, that's where this term comes from. So you have these reducers and they send actions, and then that mutates the state of your code or of your app. And what we noticed, or actually, let's take a second here. The other thing that's worth mentioning is that with Redux, you compose state, and especially with the composable architecture. So if you have like a home screen and then you have a card screen that's linked to that, your card state will be embedded inside of your home screen state. Now, what you'll notice here is that this home action kind of does everything goes through it. So if there's a cards action, that goes to home action as well, which means that this makes for an amazing choke point. And what you can do here is insert like a little bit of a listener, right? And for example, I can log all of my actions every time that they come in, and composable architecture already comes with an amazing utility to just print out all of your actions, which is super helpful. We took it a step further. And what we did is we integrated that with Sentry. So that example that you saw with, you know, having to like manually do all of that stuff, completely false. You don't need to do anything like that. What you can do if you're using the right architecture, or as long as you have enough choke points in your app, is you can just insert your tracing at the right level. And like, for example, here we're seeing that when the home router loads, this refresh spend action is triggered. All of these other actions are triggered as well. In fact, can anyone spot a bug here? Okay. You see the bug now? Yeah, we were running them all in serial, and that was like a really quick win. Like day 1 that we started instrumenting this stuff, we found that out. So that was super helpful. But yeah, those are the 3 main takeaways from this talk. And yeah, number 1 was, again, building wheels is easy with SwiftUI. And then helpers are force multipliers, of course. And dynamism is possible despite what people may tell you. That is it for this talk. And if there's any questions, I would be happy to take them. Here are some social links. And yeah, thank you.
I saw an add to Apple Wallet button in there. Is that provided by SwiftUI or did you have to use something else to get that in there?
Okay, so the question is about the add the Apple Wallet button, and whether that's provided by SwiftUI. So it's not provided by SwiftUI, but this is one of those cases where, again, we were able to use bridging, and it's like really, really lightweight. We just wrap the add the Apple Wallet controller inside of our own UI.
Provided buttons, provided features.
Yeah, no. I think they might have changed that now, like in iOS 16 or something. Don't quote me on that. But it was super easy for us to wrap it.
Curious what kind of architecture you used. You talked a little bit about Redux.
So anything in particular that
Well, I just know with SwiftUI, it's an ongoing debate about what's the best architecture to use.
Oh, okay. This is a spicy question. So the question is, what is the architecture that we're using in our app? And I would go over this very briefly. Maybe another talk, another day, we'll sort of go in it, enhance it more. But we're using the composable architecture by Point Free, and this is just a really brief overview of how the architecture is intended to work. So yeah, it's based on Redux, and which works really well with SwiftUI because like this state is automatically diffed when you use SwiftUI trees, the view hierarchy and everything. We actually have a little spin on Redux or on the composable architecture. We call it decomposable architecture. The way that works is that we have like modules that are Redux units, and they're kind of black boxes. So the outside world doesn't know that they're using Redux inside, which means that you can also like use view models in a different part of the app and compose the two things together. But yeah, like the reason for that is mainly just that we found that like having too much interconnection is also something that leads to rigidity. And if you have like these sort of decomposed units, it allows you to do things like deep linking. It allows you to do things like, improving your performance for one really easily. Yeah. But that's another talk for another day. Yeah, I think there was one more question as well.
So
Yeah.
maybe for the top, how customizable are the components? Like because in production you inevitably pop into a use case where you need like an icon on a certain side of the button or something. So how flexible is this, with like margins and
Right. Okay. So the question is, how customizable are the components that SwiftUI gives you? And I just want to highlight this bit again, which is not that. That in SwiftUI, building wheels is easy. So yeah, we did find that certain components like navigation view are not very customizable. We're not using navigation view anywhere in our app, and even the new navigation stack is nice, but it's not great. In terms of it's still a little bit buggy, and of course, like you're stuck to the system UI if you want to use like UI navigation controller or whatever. I would say the same problem exists in UIKit though, because even in UIKit, like if you try using UI navigation controller, it's insanely difficult to like push it beyond what it already does. Like how many of you have tried extending a UI navigation controller's like nav bar by adding like a tab bar right below it, for example? Like good luck getting rid of that hairline, So yeah, the point is, SwiftUI, some of these SwiftUI components are a little bit rigid, but that just means you can build your own. And Apple gives you the same tools to build your own components that they use for the most part, which means like things like this navigation stack are, really easy to build. This is not using the built-in stuff at all. This is just our own thing. And yeah, like even with, I would say the base components though these days are fairly customizable, like buttons and labels and things like that. You can configure them however you want to. So yeah, I think we're in a pretty good place as far as customizability goes.
And when you enable the themes, like back mode, for example, something easy is just like switching like a variable.
Yeah, so the follow-up is what about like enabling themes, and how does that work in terms of like, do we just switch a variable? Yeah, so with that environment object, it's as easy as changing like dark mode, the enum value from light to dark, and it propagates across the app because the environment object is injected everywhere. And unlike with, UIKit, in this case, like because we're using this environment thing, we can actually add custom enum cases. So if we wanted to use non like basic light or dark themes, we could also add like a third theme or whatever we wanted to.
Can you like that side where you had like the asynchronous, like everything was in order, like what was that?
Yeah, sure. Not that one. That was this one.
What is
Oh, this is kind of a tangential bug. I just wanted to demonstrate that, having the right utilities helps you catch things like this. But
what is this?
it's so this is Sentry. Yeah, this is Sentry's performance metrics UI. And even if you were in UI Kitland, you would have to like manually instrument a lot of these things. But with our choke points, as we call them, like it makes it really, really easy to automatically do this instrumentation. These are all network requests that don't have interdependencies, so we just parallelize them. Yeah. Oh yeah. Yeah.
But, what about pitfalls that you had? What are their downsides?
Okay. Yeah. So the question is, are there downsides to using SwiftUI? And yeah, definitely. I mean, I'm not going to say that everything is, perfect, right? SwiftUI does have pitfalls. We've often run up against them. Sometimes, yeah, it is a little bit opaque how like the diffing works. I would say that kind of relates to Swift in general being a bit opaque. If you try to instrument concurrent Swift code, for example, we found that to be insanely difficult. Like even just setting breakpoints and using LLDB is difficult with that. But that is kind of more applicable to Swift in general. As far as Swift UI goes, yeah. So I mean, a few other things that we would like are, I mean, the current app, like if you look at the way that like SwiftUI recommends using the app lifecycle, that's not ideal. It doesn't give you enough customizability. That's another thing we've been able to work around by, we are using the UI kit lifecycle and then using UI hosting controllers. But that is like still more worth it for us than going all in on UIKit. It's like I would say our code base is very minimal in terms of UIKit, like 5%, 95 is still SwiftUI. In terms of other trade-offs that you're making, and I do think it's more trade-offs than like pitfalls of either SwiftUI or UIKit. Yeah, like in a lot of cases, you are sort of giving up the ability to automatically or to sort of manually declare how like animations are going to perform. For example, like keyframes are something that SwiftUI isn't amazing at. So you'd have to like use, implicit animations or explicit animations with SwiftUI. We haven't found that to be a huge issue. In fact, I want to just quickly, if I have the simulator open, gonna bring this over here. Like we've implemented like animations like this. This is pure SwiftUI. And that's so even like in the cases where declarativity is more difficult to use, we found, or like I found personally at least, that it's just more about shifting your frame of mind to think in a declarative manner than it is about, trying to fight the type system or with SwiftUI. But yeah, I mean, of course, there's trade-offs, and there are lots of apps where you would be better off using UIKit if you're like building a messaging app, for example. And you need like customizability in terms of how the rows are rendered, and like you're rendering thousands of messages. That's the kind of case where UIKit and UI collection view, for example, does come in handy for sure. In a lot of other cases, though, what I'm hoping to drive home here is that in most cases, SwiftUI is really good.
One other question.
just in, I was actually having a discussion earlier about performance.
Mhm.
How performant, do you have any, I don't know what your scale is, but is there any concern with performance versus UI kit?
So the question is any concern with performance? And so far we haven't seen any concerns with performance in terms of since our app is architected with DCA, most of the actual business logic is done on background threads when we're using Swift concurrency really heavily here. So it's like mostly if there's any performance bottlenecks, it's like say a view is updating too often, but we've found that instruments is really useful in cases like that. And they do have new instruments that allow you to see what exactly is causing your views to re-render. So yeah, I mean, I won't definitively say that this is going to be true everywhere because I've worked on other apps where like I said, messaging, for example, you are liable to performance issues. But for the case where we don't have like millions of flows or like even tens of thousands of flows, SwiftUI works really well. Yeah. If there's no other questions, I will wrap up, and you can always find me after this talk. Just gonna throw up these links again. But yeah, thank you.